What's up, everybody? It's the Rec-Lectrician here. Today we're going to be talking about the add operator. Now, first we're going to be talking about it from the math point of view. Then we're going to be talking about it from the circuits point of view, that coding aspect. And then we're going to see kind of an application of how to use it. So let's run on over. I'm going to throw that down. All right. Then we can just talk about it first with integers. So we say, okay, super simple. We're just talking about this symbol right here, right? So most people are going to know how to do all of this stuff. So this is just going to be a little quick video here, right? So 1 + 1, 2, 3 + 5, right? 8. Super simple. If you're not maybe too good with adding negatives, just a quick refresher there. If we've got like 1 plus -1, you just got to think of the number line, right? So we have 0, 1, and -1. And so we're pretty much saying this plus this. So this amount plus this amount, they cross each other out, right? So if we looked at it and we said, okay, -3. So this is pretty much the same as saying 1 minus 1. Let me write it down over here to make it a bit clearer. So this is pretty much the same as saying 1 minus 1, right? Equal to 0. So if it's a positive plus a negative, it's the same as subtraction. So that part, we get. Now what if it's like a negative plus a negative, right? This is pretty much the exact same as regular addition, but you just add the negative in front, right? Because -1 plus -1, if we go back up here and we add in a -2, we have -1 plus this amount now we have said is, -1. Like that's how large it is. So one of these, two of these, boom, we're -2. So if we look at it like that, we say, okay, -1 plus -1, pretty much the same as saying -1 times 1 plus 1. And then this is just 2, right? Because 1 plus 1 is 2. And then you put a negative in front of it, and that's your answer. So that's just kind of like the quick and simple negative and positives for integers. Pretty similar with floats, doubles, decimals. We can just do 1 again. We say 1.01 plus 1.05. So how would we do this? Well, the easiest way is to break it up, right? So this is a section, this is a section, and that's a section. So you can label it 1, 2, 3. There's, hundredths and tens and units and all of that, but who cares? We just want to make sure we're doing it right. So now we say, okay, 1 plus 5, 6, 0 plus 0, 0. If we do that like that, like that, and 1, whoops, 1 plus 1 is 1. We have a, what's this? In between the 1 and the 2, we have a decimal, so we just plop a decimal right there. So we just say 1.06, right? makes sense. Maybe that's overcomplicated it, but just if decimals ever confuse you, it's kind of an easy way of thinking of it sometimes. So it's pretty much the exact same as over there with negatives. We're just going to do the exact same number here, 1.01 plus negative 1.5. So we have 1.05 negative. So now we do it the same way, but we're subtracting pretty much, right? Because if it's positive plus a negative, it's pretty much subtracting. So we say, okay, 1 minus 5, or 1 minus 5 is negative 4, right? So if we look at this and we say, okay, well, 1.01, 1.05. Well, we know that this is larger. So we know that if it's larger on the right-hand side and we're subtracting, it's going to end up as a negative number. So we can just put a negative right there. And we say, okay, so what is this going to equal? Well, 1 minus 5 is a negative 4. 0 minus 0, 0. 1 minus 1 is 0. So 1.01 minus 1.05 is 0.04, negative, right? So once again, that's just that pretty quickly. And we look over here and we say, okay, in terms of variables, it can sometimes get confusing just changing out what you're doing, but at the end of the day, it is the same. So we say, okay, x plus y plus x. All right. So this is just representing any number or any like specific thing you're trying to add, right? So we can say, okay, well, this is the same as this, right? We know that x equals x because they're the exact same variables. So if we were to, for example, replace this with 2 and 2, and then, for example, if we replace this with 1, right? And don't think of these as the numbers themselves, but maybe unique identifiers, right? So we can say, okay, simply enough, we have one of these, and how many 2's do we have? 1, 2. So we have 2 objects here, 1 object here. And we know that these are our x's. We know that's our y. So we can say 2x plus 1y. So in terms of making that simpler, we have 2 x's and 1 y. Because if we just count 1, 2, there's 2 of them. We count that, there's 1 of them. The point of this is just kind of to wrap your head around the logic. Even though it's super simple, when you make things complicated, the simple stuff can get pretty complicated. So, we're going to drop that real quick. Pick this up. Run on over to here. We've got the add already. Perfect. So, let's look at the add, right? On our left, we've got our inputs. On our right, we've got our outputs. So we say, okay, what are our inputs? So let's go over to the wire tool. Hover over it. It says we can use int, float, or vector. Okay. I believe the 3 is referring to the fact that it's 3-dimensional because it's got 3 different variables within it, x, y, z. So we don't really need to worry about that now, though. But if you know about it, you know that you can use it, right? So simply enough, integers, floats, we can add them. Now, awesomely enough, if we just throw in from our palette real quickly an integer, search chips. Oh, I feel like they've updated that. Primitives, int right here, right? And we're going to do a float over here. And then over here, we're just going to add an event, and that's pretty much just giving us the ability to run this program, right? And I'll explain a bit more about that right now. And definitely have a video on it later, but event receiver, throw that up, we throw our wire up, and then we throw it to there, We throw that to there. So what is this doing, right? So this is the execute, and it happens sequentially. So what that means is this is going to happen first. Our event receiver is going to get called however we set it up. Then the signal is going to go from there into our integer. Going to go from the integer into the float. We don't need to hook it up to the add because it doesn't actually have this red/orange piece, right? So it doesn't wait for an execute signal to output its sum. It just does it based on what the input is. So if you want it to wait, you could make the input change based on your execute, and then check pretty much when this changes over here, that execute goes after the add and then checks once that's changed. So that's a way of like setting it up like that. But pretty much we're just going to show you that you can add 0 and 0, right? So if we just add 1 plus 1, we know it is 2. So let's add 1 plus 1. Enter. You see there's no execute going in here. What's the sum? The sum is 0. Why is it 0? Because we haven't actually executed the integer setup. It's been set up as 0. So let's go over here, click configure, click on our event receiver, chip setup, event. We're going to do test event. We're going to do that. And then we're going to go back to our wire tool. And then we see 1, we see 0. We go over to circuits, send test event. So now we've started our program. And what is the answer? 2. 1 plus 1, 2. So now this is an integer. This is a float. We haven't set the float up. So let's set the float up and see. We know we can add an integer with an integer, but can we add an integer with a float? Invalid type. Well, that's because we're probably trying to hook it up. So if we take that away and we do that, so it seems it doesn't let us do that. Now, what you can do is you can do search chips. We can search float. Float to int. Not float to int. It's there somewhere. Don't you worry. They might not let us do it because of the possible problems with turning a float into an int. But yeah, they probably don't let us do it. Yeah, but that's fine. What we can do is this. We go move. And what we would say is we say, okay, well, we can't hook up an int to a float. And we can't hook up a float to an int. But what we can do is hook up an int to a float by doing this. So this is an int to float. And so it converts your integer, let's say 1 or 2, into a float, 2.00 or 1.00. So let's just close that, throw it into our value. The result is now 1. As you can see, this is changed to blue. So we're using an integer and we're using a float, right? 0 plus 1 should equal to 1. Now, the reason it changed is not because this is equal to 0. Let me just demonstrate that real quick. Wire back up. So the reason it changed is because, remember, the add isn't waiting for an execute. So all we've actually done is taken out the 1 and then taken out 1 plus 1 and just added 1. Because the plus is just 0. Not because of that, but because even if we took this away, it's still 1. Because this hasn't been executed yet, right? When I set that to 1. So, also, I mean, it's already set to 0, so technically that does work. But if we, for example, set this to like 6, boom, that's 6. This is still 1, right? We slap our execute, send test event, boom, boom, 7, right? So this has been how to use the add operator. Understanding that when you change the input, it will change the output immediately. It doesn't wait for a signal. The signal is the input. So keep that in mind if you ever confused a little bit there. And this is just kind of a little quick implementation of it. In terms of the use, Real quick before we close this up, we can just show it with a search chips. We'll do a delay right there. All right. So if the wire running to there, all right, I'm running this wire to there, and then it's taking in a number. So now we're giving it 7, right? So we can, not that you would use it for this, but we can then take that float or that integer that we've added with whatever we've got to the left side of it, and input it into something else. For example, like a delay, or maybe you're trying to move your AI a certain distance, and you want to calculate it based on maybe some of the trigonometry we learned earlier, plus like the distance of certain objects in its way, or certain things like that. But yeah, this has been the add operator. Thank you so much for watching. If you like it, let me know. If you think there's anything I missed, let me know. Thanks so much.